Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to cover on the introduction to object-oriented programming. Okay. So when you are doing coding, you are basically trying to solve a problem. Okay, for example, before this, maybe the operation is being done manually where you have written in on a paper, right? So what we are trying to do, we are trying to convert that problem, that manual process, into an automated process, for example, where you allow key in the data to be entered from the keyboard and so on, right? So the key to design a solution is to break it down into manageable pieces. So if you are doing coding, basically, in order to solve a problem, you have to break the problem into a smaller pieces. And when you have broken it down to smaller pieces, then you can convert it into codes. Okay, basically, in learning programming, there are the most two common methods are, the first one is procedural programming, okay, and the second one is object-oriented programming. Okay, procedural programming is a bit is slightly an older approach. Okay, people are still using it outside, and again, in doing the coding, the main problem is also still being divided into smaller pieces, or it is divided into sub-problems. Okay, all the sub-problems or sub-tasks are implemented as procedure. Okay, just like the one that you have done in your object-oriented programming before, where you learned that in object-oriented there are methods, right? It's the same. In procedural, they also have the methods. It's just that the data that is used in that operation or in that method is not put together. It's normally passed from one procedure to another. So these are programming language that is supporting procedural programming. Okay. So in procedural programming, the data and the methods are not in the same place. It's being, if for example, a method, in order to do an operation, the data has to be retrieved from somewhere else. Okay, and then it is being passed, and then the operation is done on the data. It's slightly different with object-oriented. It's also using the same approach in solving the problem, where the problem is broken down into a small pieces. Okay, and the difference is that the data and the procedure or the methods are in the same place. Okay, so in the object, you have the data and also the operation in the same place. Right? The common programming language, the object-oriented programming is supported by C++, C#, Visual Basic, .NET, and also Java. Okay, so the advantages of object-oriented is that it allows code reuse. Why is that so? Because when you have objects, you have the method and the data together, right? So you will have several classes. So for example, you have student class, course class. So you can use student class in a different project, or you can use course class in a different project, so that it allows you to allow code reuse. So you don't have to do the coding from zero. You can actually recycle some of the existing classes. So programming in this way, where you put data and methods together, represents real world object. It's like you as a person. Okay, you have name, all the information about you and what you can do in one, in you yourself, right? So you don't separate your name somewhere else and what you do somewhere else. And it allows better process and data management of the objects. Okay, in object-oriented, there are four main elements: the object, the class, the attributes, and the methods. Alright. Okay, object is actually it comes from the class. Okay, the class is the description. Okay, the codes that you have written inside the class. You have data. Okay, the methods, right? So objects is the executable form of the class. So it's actually a real world object. It's a thing. Okay, can both be tangible or intangible, right? So when you are this, so this is what I mentioned to you just now. A class is the definition. You have to write it. So it contains the code, and when you run the class code, it becomes object, or sometimes it is called instance of the class. So object and instance of the class is actually referring to the same thing. Okay, from one class you can have, let's say you have a class of student, you can have multiple objects of students when you executed the code. Okay, so this object will be in the main memory. So when the code ends, the object will be removed from the memory. So it's gone. So what is remain is only the class. Okay, so don't get confused with object and class. Class is the code that you written, and object is the class which is in the running form when you execute it. When you compile, you run, right? So what you see running on your IDE is actually the object. Okay, so the class is written by you, the programmer, whereby the object is created when you run the code. Okay, when you run the main method. Okay, attribute. I think by now you are familiar with attribute. It's actually referring to um, the property, meaning that whatever data that you use in the class, okay, name, age, ID, and so on. Operation. Okay. In the class, you have operations, right? Operations basically representing the action that can be done by the objects, right? And these methods, or sometimes called operation, we can call it by invoking the signature. What does it mean by signature? This is the signature. The name of the method, the variable, the parameter or that is used, and what um, written value that this method will return. Okay, so when you heard about signature, method signature, we are referring to this. It's like the name of the methods. Okay, objects. So I said to you just now, objects is referring to the running form of the class. Okay, so for the object, you will have state and behavior. So when you heard about object state, it's actually referring to whatever value that this object is currently having. Behavior is referring to the methods. This is another example for bank account. So you have a bank account when initially you will have the bank account class first. And then when you run it, the bank class code, it becomes bank account objects. Object will have state and behavior. So state is actually referring to whatever value that you give to the object. In this case, the bank account, or whatever behavior, what kind of action or processes that this object currently having. Okay, so the code that you have written can actually be represented in a form of diagram, and the one that we are using throughout the course is actually called Unified Modeling Language, UML class. UML. UML itself, there are many diagrams, but the one that we're looking at right now is the class diagram. Class diagram basically is showing the graphical form, the visual form of your class that you have written. Okay, so you have class name, whatever class that you are written, and then the front part here, the upper part is referring to the data, the attributes that you use for this particular class, and then whatever operation or method that this class is supporting. For example, this is an employee class. The upper part is actually the attribute, whatever data that we want to use for this particular class, and the lower part here is basically showing the methods. What are the operation that you want this employee class to do? For example, you want this employee class to be able to set the last name, set the hourly wage, okay, calculate weekly pay, and so on. Okay, this is an example of another class diagram for student. Okay, the upper part here is all attributes related to students, whatever that you want to define for that student, and then the lower part is the method. Okay, for example, this is student class. The method relates to student class is, for example, calculate fees, calculate CGPA. So, okay. So when you run your class, you basically get objects. I mentioned to you just now, object is sometimes called instances of class. So when you run your class, you can have many objects. Okay, how is that can be done? For example, you have like you. There are many UUM students, right? So you can create. You first need to define the student class first. You written the code first, and then when you run it, you can create multiple objects. Each of the objects can have different values. Okay, this is objects for Abdullah. This is object for Achok, and so on. Okay, this is another example. Let's say you have a class for dog. Okay, so all this attribute name is related to dog, and all these methods here is also related to dogs, and you can create many objects, many instances. Each one will have slightly different data, different state, and different method. Okay, so what we have covered so far just now is the main element of object oriented. So basically it has class, objects, attribute, and methods. Now we are going to look at the characteristics of object-oriented programming. So basically, whatever programming language that you use, if it is an object-oriented programming, it will normally apply these four characteristics. The first one is abstraction. Okay, abstraction is actually referring to um, hiding complexity. So whenever you are doing programming, your codes, you do not want to show the detailedness of your code to other people. Okay, you just want to show, only want to reveal what that object is and what it does. Okay, how you do the code, what kind of variable inside, you don't want to show it. Okay, only the programmer, only you know what is inside the class. For the others, let's say you have your friend, you, if they want to use your object or your class, they don't have to know what is inside. It's simply called your class. Okay, for example, I think you've been using this right before, maths.pow, which is to get the power. So you simply use it, right? You simply use maths.pow and then you put whatever value here, and then you get the results. You don't really know what's happening in this method pow in the maths library, right? So that is the concept of abstraction. You want to hide the information. You don't want to reveal everything. What you want is ever use your class, only have to know what it does. how it is being done, what kind of processes inside in the class. You don't want to show it to other people. Okay, the second concept is called encapsulation. Encapsulation is the process that I have been mentioned earlier, where you have object data and methods is inside a single unit. In our case, you are referring to class. When you write a class, you put data and methods related to, for example, for a student, you put all about data of the method and method done by students in one class. Okay, the data are frequently hidden from the outside class. Okay, I mentioned to you just now, we don't want to show to the outsiders other than you as a programmer what is inside the class. Okay, especially the data. And you can only access the data from the method, which can be accessible to the outside classes. Okay, how will that be done? In the encapsulation, there is a concept of data hiding. The concept that allow classes, that concept that other classes, let's say you are writing a student class, you do not want other classes, for example, course class, to modify whatever data in your student class. Okay, let's say you have a student name for defined in your class, and then you have another object called course. Okay, let's say you want to modify the name of the student. You do not want the course class to modify it. You have to force so that the changes of the name of the student is done in the student class itself. Okay, that's how you control who can modify what. Okay, an object protects and manages its own information. If it's a student object, all the data or the method is controlled by the object itself. Right? More example on encapsulation. Right? So normally, I think you'll be learning this again. The concept of encapsulation make use of the private access and public access. Okay? Normally, remember you have a class, you have data and method. The data is normally set as private. You do not want other class to access it. Whereby you will make the method, the lower part, right? The method to be accessible to outside class. Okay, so let's say you have in your class, there is a variable called grade. Student, let's say the INASIS of the student. Okay, as a attribute. Okay, you do not want INASIS data of that student to be changed by another class outside. Okay, can only be done by the inside the class. And in order to allow that to happen, you will make the method inside the class for changing INASIS as public. Okay. Note some methods can be also be private. Okay, so you can have method not only make it public but also private as well. Okay, in class diagram, if you see a minus sign, it means that is referring to private. If you see plus sign, so that is referring to public. So if you draw a class diagram like this, not only that you only specify the name, you can actually specify where the access, whether it's a private, so this one is private, all these are, the plus sign is public, so it can be accessed by other class. But if you can see here, you have calculate week pay method, this is set private, so it can only be accessed in this class only, employee class. The third concept or characteristics of object-oriented is called inheritance. Okay, inheritance is it allow a new class. Let's say you want to create a new class, it can be created by extending an existing class. Existing class is the parent class. Okay, so you don't have to create a class from scratch. You have to go and check first whether there is a parent class already defined in your codes. Okay, the new child class inherits the members of the parent class instead. Okay, so what this means? Okay, for example, you want to create a class student. Okay, then when you see, oh, there is a class person already, and you see that this class person here, there is the variable, the attributes here can be used by your class that you want to create, in this case, the student. So you can extend it. Okay, you can inherit from the superclass or parent class. So if you see this kind of diagram, so in the class diagram, this one is showing the inheritance. So the upper part here is the parent class or the superclass. The one that extend this one here is actually um, the child class or the subclasses. So whatever inside in the superclass can be used or can be inherited by the children class or the subclasses, right? So student, if you are in the student class, you can actually use the variable or the method in the parent class. So that is the concept of inheritance. Okay. The last concept is called polymorphism. Okay. Polymorphism. Okay, polymorphism, what it means is that refers to objects' ability to take different forms. What that means is that it allows you to create methods with the same name but different implementation in different classes. So, if I can show it visually, it's like this. Okay. Polymorphism means the variable name is the same. Okay, this example here is showing superclass here, the parent class, and the subclasses or the child classes, right? So the parent class is shape and the subclasses are circle, square, and triangle. And you can see that this name of variable, the name of method is the same. Okay? And it's not only is the same, and they are in the different classes. Okay? This is allowed in object-oriented because what this allow you is that, for example, this is circle, right? Circle. So if you still remember, when you want to calculate the area of the circle, the formula is different compared to square. So this method basically do the same thing, which is calculate area, but this one here in the circle have different formula, this one here in square have different formula, and triangle in triangle class calculate area has a different formula. The name is the same, but the implementation, the code inside it is different. Okay, alright, thank you so much. We'll continue in the following slide for more information.